Hi and Assalamualaikum. My name is Amir Najah binti Masari. My matrix number is 229330. So today I will be presenting about fluid properties and their engineering application. So for introduction for this topic, engineers frequently design projects that require fluids or even lubricants such as engines and pipelines. Therefore, it is important for engineers to know how fluid will behave in certain conditions and pressure differences. So first, we have viscosity. A simple definition for viscosity is a measure of fluid's resistance to fluid. So for its application, viscosity behavior changes with temperature can assist to choose the suitable lubricant to work in certain conditions. As an example, brake fluid alters the force through the system of braking, which is not operated properly and thoroughly with distinct viscosity. Other than that, in the pipeline transportation of chemical viscous liquid, such as oil and liquefied natural gas, it is necessary to fully consider the potential impact of the viscosity of this liquid on the transportation efficiency to ensure its safety and continuity. So a conflict engineering issue regarding viscosity is engineers can calculate how fast the fluid will move over time by knowing its viscosity. At every gas station, the pumps are designed to measure the volume of gasoline being purchased. By knowing the viscosity of the fluid and the force being applied from the gas pump, engineers can calculate the velocity that the gas will move. Thus, along with the dimensions of the gas nozzle, the amount of gas being purchased can be calculated. Next property is compressibility. So the simple definition for compressibility is the ability of a fluid to change its volume in response to changes in temperature. So for the application for compressibility is understanding the compressibility to predict and analyze fluid flow behavior, different scenarios accurately. In engineering, compressibility of fluid helps to determine the behavior of materials under compression, aiding in designing structures that can withstand external forces. The compressibility of fluid plays a crucial role in various applications such as aircraft design, gas dynamics, and hydraulic systems. A conflict engineering issue regarding compressibility is in the oil and gas industry, subsea pipelines transport crude oil and natural gas from deep underwater reservoirs to processing facilities. This pipeline must withstand extreme pressure changes and deformation due to both internal fluid pressure and external ocean depth. Engineers solve this problem by using duplex stainless steels or high-strength carbon steels with corrosion-resistant coatings. These materials have maximum mechanical strength, fatigue resistance, and low compressibility. Lastly, we have density. So a simple definition for density is a ratio of mass of fluid to its volume. So application for density is in building structures and buildings. Engineers are required to know the density of particular materials such as concrete, steel, and wood to ensure the stability of structure. Frequent changes in temperature will affect fluid density due to its thermal expansion and contraction, which can have negative impacts in their application. For example, in processes involving heat exchangers, engineers must account for changes in density of fluids when designing a system to perceive the accurate flow, rates, and mix. Lastly, a conflict engineering issue regarding density is in offshore employment. Multi-phase flow pipelines are used for oil production in which water, oil, and gas flow together. As in this case, water has higher density than oil and gas. If the process is managed improperly, it will cause slug flow in the pipeline and eventually leads to fluctuation and malfunction of equipment. To solve this, engineers equip modern pipelines with automated control valve and variable speed pumps that adjust in real time based on feedback from sensors monitoring flow rate, pressure, and temperature. So to conclude everything, knowing how fluid behave in certain conditions is fundamental, especially for engineers, to know the most suitable fluid to use in their project. Core features including viscosity, compressibility, and density plays a crucial role in dynamics of fluid from how it behaves in pipelines to climatic occurrences. That's all from me. Thank you.